In this video segment, we are going to practice how to determine the number of subatomic particles, protons, neutrons, and electrons, present in either an atom or an ion, using information that has been provided about mass number, atomic number, and ion charge, if any is present. A review of what we learned in the last video segment, that ions are formed by atoms either gaining or losing electrons. We never alter the proton count in the nucleus when we're looking at chemical changes. Nuclear changes are a bit different, and we'll get to that in the next chapter, but this class focuses on chemistry, as in standard chemical changes, and proton count stays constant in atoms when they're undergoing chemical change. It's only the electrons that are changing. So if we call something a cation, we're referring to it as a positively charged ion. That means it has more protons in its nucleus than it has electrons, which are negatively charged, surrounding it. That means the atom had to lose electrons in order to have this imbalance of more protons in the nucleus. Remember, the charge on a proton and an electron is equal and opposite in charge. So because we have more positive charge than negative charge, the ion has an overall positive charge and is referred to as a cation. Anions are negatively charged ions. That means they have more negative electrons circling the nucleus than protons present in the nucleus. More negative charge than positive charge gives them an overall net negative charge caused by the atom gaining one or more electrons. Now let's see if we can take this information and use it to fill in this following table. So if you do not have this ready at hand, I suggest you obtain a periodic table that's either in the front cover of your textbook, or you can print the PDF file out that gives you a periodic table to use. It will be very important throughout the rest of this semester. So let's go ahead and together we're going to do this first example on the table. And then I'm going to urge you to pause the video while you try to fill in the remaining vertical columns and see, with the information given, can you fill in the rest of the information asked for the species in the vertical column? And notice mass number, atomic number, number of protons, number of neutrons, number of electrons, and is there a net charge on the atom, which would make it an ion? Information about that could be provided or asked of you, as you see in the examples. So let's do this first one together. It's the easiest example as a kind of warm-up. Right, so you see the chemical symbol Ag of this element, and of course you've memorized the names of elements and their symbols that you were told you were responsible for. So you should look at this symbol and recognize it as the symbol of the precious metal silver. Notice I have not written anything in the upper right-hand corner. If nothing is written in the upper right-hand corner, that is the space reserved to indicate charge, if any, on an atom. So if nothing is written in the upper right-hand corner, you understand this is a neutral atom. It has no net charge to it. If that's the case, then you immediately know that the number of protons and the number of electrons have to be the same in any neutral atom. So that's important information that you're bringing to the table as you look to complete this. And of course, in our previous video, we discussed the fact that a number in the upper left-hand corner is the mass number of the species of the isotope. And a reminder that mass number is the number of protons plus neutrons. a number in the lower left-hand corner, so upper left-hand corner, mass number, lower left-hand corner is the atomic number, which is the number of protons only. And you see that I did not give you information about the atomic number of silver. And you should not expect me to give you that if I have given you the symbol of the element, because the periodic table will tell you what the atomic number is for each element. Remember, the atomic number, the number of protons, determines the identity of the element. All atoms of the same element have the same atomic number. So I'm looking at the periodic table, I'm finding the symbol for silver, and I see the whole number 47 appearing in the box with silver. That whole number is the atomic number for silver atoms. So I can immediately fill in the information from this table that we just discussed. I know that the mass number for this isotope of silver is 108, and I know the atomic number is 47. The number of protons, in other words, is 47. Because it is a neutral atom, I know that the number of protons has to be equal to the number of electrons, and I can fill in 47 for the number of electrons as well in this neutral silver atom. And that leaves us just one last thing to calculate. What is the number of neutrons? Well, we can see here easily that if we subtract the atomic number from the mass number, the number of protons cancels and we're left with the neutron count. So you can either do this in your head, I know you know how to subtract, or on a calculator. Just get it right, especially if it's a quiz or an exam, and double check your work. So I did the subtraction of 47 from 108, and I'm going to repeat that, and I get the same number both times. So I'm putting down 61 for the number of neutrons present with the number of protons in the nucleus. And I always like to do a double check, just adding these two numbers up, proton count, but plus neutron count should take us back to the 108 mass number for this isotope. So we have finished this first column of this table. And now I would invite you to put this video on pause and let's see how you do with filling in the next 3 columns on this table. Notice it's getting progressively harder. In the second column, I do not give you the symbol of the element. You have to figure that out from the information that is provided and some deductive reasoning. The examples get a little bit harder as we progress through. So why don't you pause this video and see how you do completing this table. Alrighty, we're back, assuming that you've paused, and we're going to take a look at how you did at completing these remaining examples. So in this second example, you're not given the symbol of the element, but you are told its atomic number. And as soon as you know what the atomic number of an element is, which of course is the number of protons present in the nucleus, so we can immediately fill in atomic number is 17, number of protons in the nucleus is 17, and we can go right to the periodic table, look at the box that has an atomic number of 17, and immediately identify that this is a chlorine atom, or perhaps it's an ion. Let's see what the rest of the information reveals. This example told us the number of neutrons, so knowing the number of protons and the number of neutrons, we can add them together and come up with the mass number of this particular isotope of chlorine. it's a chlorine 37 isotope. Remember that we name isotopes according to their mass number. My eye is also immediately seeing that this is not a neutral atom. The proton count and the electron count are not the same. I have one more electron, or there is one more electron in the species than there is protons. So it has acquired extra electrons. That makes it an anion, right? And thinking about charge, we have an 18 minus and a 17 plus. That gives us a charge of -1 due to the fact that it has acquired this extra electron with a -1 count. One more electron than protons, therefore it has a negative charge. This is a good point to mention. Professor Wood, does it matter whether or not you put that negative charge before the number or after the number? And the answer is no, it doesn't. If you write a 1 with a negative charge after it, I totally understand what you're referring to. This is still an anion with a -1 charge. It does not matter whether the sign comes before or after the number, as long as it is the correct number and the correct sign. Right, so we have here, let's make sure we fill this in. Now I need to indicate that this is not a neutral chlorine atom, it's a chlorine anion, and its name actually changes once it becomes an anion, and we call it the chloride anion. So this is a chloride 37 anion with a -1 charge. Let's take a look at the next example, our third example. A little bit harder because we neither have the symbol nor the atomic number nor the number of protons. So we're going to have to do just a very quick calculation in order to get that proton count, which of course is the atomic number. And as soon as we have the proton count, we know the identity of the element we're looking at. How do we get that proton count? Well, we know the mass number is 88 and the number of neutrons present is 50. So if we subtract the neutrons from the protons and the neutrons, that should give us the number of protons present. Again, subtracting neutrons from neutrons and protons should give us the number of protons. And I think that this is pretty easy to do by inspection. 88 minus 50 gives us a proton count of 38. And once we have a proton count of 38, we can look at the periodic table and now we know the identity of the species. It's a strontium ion, I see, with a +2 charge to it. So strontium 88 cation with a +2 charge. So that proton count is 38. That's how we know it's strontium. That is the atomic number. And I could write that 38 in if I wanted to and complete this notation. Let me write that a little clearer, little scrunch there. So, atomic number in the lower left-hand corner, mass number in the upper left-hand corner. We only have one box left to fill in. This is the number of electrons present. Now this is a cation with a +2 charge, right? How did it become a cation? It became a cation by losing electrons. It had to lose 2 electrons in order to give it 2 more protons than it has electrons. So I'm putting down here a 36 for the number of electrons present in this species. It lost 2 electrons. Now it has more protons in its nucleus. So Each proton plus 1, there's 38 of them. So a 38 positive charge in the nucleus, but only 36 electrons surrounding the nucleus. 38 positive added to a 36 negative gives us a +2 if you want to check it mathematically. Or if it loses 2 electrons, has to have 2 more protons than electrons, and that explains our +2 charge. So several different ways of looking at this. Our next example is the most difficult of all, because I don't give you the symbol, the mass number, or the atomic number. Instead, what you're given is the number of neutrons, the number of electrons, and the charge. This is an ion with a +3 charge. It is also a cation. So we've got to get that proton count in order to identify the element. You have to know what the atomic number is, number of protons. We're not going to be able to figure it out directly from the number of neutrons because we don't have the mass number. But we do have the number of electrons and we have the charge on the species. So we can figure it out that way. It's a +3 cation. That means it had to lose 3 electrons. It has to have more protons, specifically 3 more protons than it does electrons. Well, if it has 10 electrons, it has to have 3 more protons. That means it has 13 protons in its nucleus. And just doing that addition, I see that the 13 positive charge plus the 10 negative charge adds up to +3. So it has to have 3 more protons than electrons, giving it a proton count of 13 and an atomic number of 13. Looking at the periodic table, an atomic number of 13 means that this ion is an ion of the element aluminum. So we're looking at an aluminum +3 ion. And I could put that atomic number in the lower left corner. Oftentimes, I don't bother to write it on a quiz or an exam because the atomic number is always on the periodic table for you to reference. Last thing we need to find out is what the mass number is. We know that the mass number comes from the proton count plus the neutron count. 13 plus 14 gives us a mass number of 27. This is an aluminum 27 cation with a +3 charge. Now on a quiz or an exam, I probably am not inclined to fill out all of this table like this. It's a lot of time to do that and it takes a lot of space. So I could do something as simple as giving you the symbol of an element. Right? So here is the element iron, right? Very important element in terms of the Earth, Earth's surface and core of the Earth. It's also an important element biochemically. Iron is an important ion that is a component of the molecule hemoglobin, responsible for transporting oxygen throughout the body. So this is an iron 56 isotope, and it is also a cation with, well, I said +3, let's mix it up here. We just did a +3. Iron can exist in several different charges, and in the form of hemoglobin, it is in its +2 state. So let's see if you can't figure out the rest of the information here just by giving you iron 56 with a +2 charge. Can you complete the rest of this table? And you might want to pause the video right now and go ahead and do that. Hopefully you've had a chance to fill in this table, and let's see if we can't just correct our work, figure out what we have filled out here, right? So we already know the mass number is 56. We know that it's an isotope of iron, so if we look at the periodic table, it tells us that iron has an atomic number of 26. So that means there are 26 protons. Oops, getting ahead of myself here. No, not. That's the right square. We know there are 26 protons in the nucleus. That is the atomic number of iron. If we have the mass number and the atomic number, we can do a quick subtraction and come up with 30 for the number of neutrons that are present in the nucleus of this iron ion. Okay, how many electrons does it have? Well, it's a cation with a +2 charge. That means that it lost 2 electrons. So if it has 26 protons, the neutral atom would have 26 electrons, but it lost 2 of those. So that means it has 24 electrons, 26 protons. We add those two numbers up and their charges, we get a +2 for this species, where all I needed to do was give you the symbol, mass number, and charge, and you can fill in the rest of the information on this table.